Welcome everyone. In this video, I am going to discuss how to solve integration using miscellaneous transformation. This is part 2. In part 1, we have discussed two rules, and this is continuation of the earlier video. So we consider now rule number 3. So look, dx by px plus q whole to the power n into ax square plus bx plus c. So transformation is px plus q equals to 1 by z, or we can use suitable trigonometric transformation, or you can use any method. There is no unique method, I am saying repeatedly. So but if you use this method, px plus q equals to 1 by z, or using transformation, it can be put into standard form, and making it into standard form, we can integrate it. So look, problem number 1. dx by x plus 1 into x square plus 1, dx by x plus 1 into x square minus 1, dx by x into x square plus 4x minus 4, and dx by x plus 1 into x square plus x plus 1. Now look, so from 1 and 2, so look, within root x square plus 1, this is x square minus 1. So it will be simple if we use trigonometric transformation. First we consider any one of them. Suppose problem number 1. So we can look, problem number 1, dx by x plus 1 into root over x square plus 1. We can put x plus 1 equals to 1 by z. I will discuss it later for the problem number 4, but using trigonometric transformation, it will be simple. So look, x equals to tan theta. So what is dx? Sec square theta. So because it is of x square plus 1. So dx by tan theta plus 1. What is dx? dx is sec square theta d theta, and 1 plus tan square theta is sec theta. So finally what we are getting? Sec theta by tan theta plus 1. So sec is 1 by cos, so 1 by, so sin theta by cos theta, 1 by cos theta, and look, this is sin theta by cos theta plus 1. So finally what we are getting? So we are getting this form. So cos cancel, cos cancel, d theta by 1 sin theta plus cos theta. Now this is free from root. Now what is the rule of this integration? So we can replace tan theta and cos theta in terms of tan theta by 2, then put tan theta by 2 equals to z. Or since it is particular case, so you know, if you divide by 1 by root 2, 1 by root 2 sin theta, this is 1 by root 2 cos theta. So this is balanced by this. So look, 1 by root 2 outside, we are getting a formula, well known formula. What is the formula? We can write it sin theta plus pi by 4. You can also express it in terms of cos theta minus pi by 4. So 1 by root 2, look, cosec theta plus pi by 4. So now this one is standard form. This is our main aim, to put it in terms of standard form. So 1 by root 2 log cosec theta. So log cosec theta plus pi by 4 minus cot theta plus pi by 4 plus c. Now we have to express it. Tan theta equals to x. Now we have to express it again in terms of x. In this case integration is simple, but you have to express tan theta in terms of x. From tan theta you have to find cosec theta plus pi by 4 and cot theta plus pi by 4. Putting the value, you get result. So this is one drawback. You have to put it in terms of x, it will take time. You have to convert theta in terms of x. Now look, So in indefinite integer, answer may be of different form. We can write it in terms of cos, then answer will be in terms of integration of sec theta minus pi by 4, but one can be converted in another form. So problem number 4. So look, dx by x plus 1 into root over x square plus x plus 1. So look, in this case, this is transformation is x plus 1 is 1 by z. So dx equals to minus 1 by z square dz. We can also use trigonometric transformation. Then you have to express this one as a sum of two square. So dx minus 1 by z square dz. What is x plus 1? This is 1 by z root over 1 by z minus 1 whole square, 1 by z minus 1 plus 1. Now look, 1 z is cancelled out. So minus 1 by z dz. Now look, this is 1 by z square minus 2 by z plus 1 plus 1 by z minus 1 plus 1. So 1 1 cancel. So look, if we take LCM, z square is LCM. So minus cancel, root over z square outside z, so z cancel. So what we are getting, dz by. So look, this is LCM, 1 into z square, that is z square, 2 by z plus 1 by z, so minus z. So this is minus z and this one is 1. I think this is of the form. So z square dz by this. Dz by root over z square minus z plus 1. Now this is, you have to express it in terms of sum of 2 square, sum of 2 square. So integrating you get result. So z square minus 2 into z into half, 1 by 4, 1 minus 1 by 4. So dz by root over z minus half whole square plus root 3 by 2 whole square. So this is of the form root over x square plus a square. So log of z minus half into root over z minus half whole square plus root 3 by 2 whole square plus c. Now putting value of z, we get value of the integrand. So we can put trigonometric transformation or this linear equals to 1 by z. Now we consider rule number 4. dx by ax square plus bx plus c root over px square plus qx plus r. That is, both are quadratic. One is within root over, another is free from root. So what is your transformation? So z equals to 1 by x. This is 1. Z equals to 1 by x. Or px square plus qx plus r equals to xz, or use any trigonometric transformation, or use any, so rule will be this one, sorry, a rule px square. So that is why px square plus qx plus r equals to xz, or use any suitable trigonometric transformations. So we consider any one of them. Suppose problem number 1. So dx by x square plus 4 into x square minus 4. So using trigonometric transformation, so what is your rule? X equals to 2 sec theta. So we use this transformation. So put z equals to 1 by x. So dx equals to minus 1 by z square dz. So dx, x equals to 1 by z. So look, this is minus 1 by z square into dz. So this is 1 by x square, 1 by z square, x equals to this. So 1 by z square plus 4. And this one is root over 1 by z square minus 4. So finally what you are getting, minus outside. So this is 4z square plus 1, and this is root over 1 minus 4z square. 1 minus 4z square, and denominator is z cube, and this is minus 1 by z square. So this is z dz. Now look, if we put z square, again z square equals to p, z square equals to p. So what we are getting, z dz equals to dp by 2. So minus dp by 2, 4p plus 1 into root over 1 minus 4p. Now we are discussing how to solve dx by x square plus 4, x square minus 4. So putting z equals to this, and after simplifying we are getting this one, dp by 2, 4p plus 1 by 1 minus p. So look, so finally half outside, minus half outside, dp by 4p plus 1 into root over 1 minus 4p. So look, so why we are putting this transformation? Because we know it from rule number 1. So this one is linear, this one is linear. So calculation will be simplified. That is why, look, this form reduced to rule number 1. So both are linear. So what is the transformation? Put 1 minus 4p equals to z square. Then proceeding it in the same way, we can put it in terms of standard form. Now this is one method. Now this one, if both are quadratic, it will take time, the problem will be lengthy. Now what is the second one? Second one is using trigonometric transformation. So look, number 1, x equals to 2 sec theta, dx equals to 2 sec theta tan theta. So we are getting 2 sec theta tan theta, and this is sec square theta plus 4. Now root over, this is 4 sec square theta minus 4, 4 common, so 4 into sec square theta minus. So I think 2 is cancel out, sec square theta minus tan theta, so sec theta by sec square theta plus 4 d theta. So we are getting integrand in this form. Now writing it in terms of cos, so 1 by cos theta, this is 1 by cos square theta plus 4 d theta. So finally what we are getting, cos theta d theta by 4 cos square theta plus 1. Cos theta d theta by 4 cos square theta plus 1. Now this one is simple. So look, whose derivative is cos theta? So sin theta equals to p. So cos theta d theta equals to dp. Now this integral reduces to dp by 4 into 1 minus sin square theta. So 4 into 1 minus z square plus 1. So dp by 4 into 1 minus p square. So dp by 5 minus p square. Now look, this one is in standard form. So 1 by 2 root a, so 2 root 5 log root 5 plus p by root 5 minus p plus c. Then put value of p. So what is p? Log sin theta plus root 5. So root 5 minus sin theta. So if you no confusion, if you take this. Now this process has also drawbacks. So what is the drawbacks? Again, what is our transformation? So again you have to convert this theta in terms of original variable x. So this you can use trigonometric transformation, z equals to 1 by x as you please. But if both are quadratic, so process will be lengthy. Now we consider rule number 5. If the integrand is rational function of x to the power a by b, x to the power p by q, x to the power u by v dot dot, Then put x equals to z to the power n. So what is n? N is LCM of, look, order of the this P, Q, V. N is LCM of B, Q, V. So our aim will be to remove roots, 1 by A by B. So this is Bth order root, this is Qth order, this is Vth order. Our main aim will be to omit root. So let us consider problem number 2. So dx by 1 plus x whole to the power half, 1 plus x whole to the power 1 by 3. So p is, look, this is 2, this is 3. So what is x? X equals to z to the power LCM of 2 and 3. That is z to the power 6. So what is dx? 6z to the power 5 dz. So we are getting 6z to the power 5 dz by z cube plus z square. So z square common, 6 outside, we are getting z cube by z plus 1 dz. Now this is simple form. So denominator is linear, so we have to use division rule or adjustment rule, z plus 1 dz. So finally, look, this one is z cube plus 1 by z plus 1, 6 into integration of z square minus z plus 1. This is quotient if you divide, minus 1 by z plus 1, total z. So finally 6 into z cube by 3 minus z square by 2 plus z minus log 1 plus z plus c, where z equals to, what is z? Where x equals to, where 1 plus x equals to z to the power 6. That is z equals to 1 plus x to the power 1 by 6. So this is standard form integrating, we get result. Similarly, look, for the problem number 1, this is 2, this is 3, this is 3, LCM is 6, x equals to z to the power 6. For problem number 3, 2 and 4, x equals to z to the power 4. Problem number 4, x equals to z to the power 6, LCM of 3, 6 and 3. So you solve the rest of the problem. Now the last one, rule number 6. If the integrand of an integral contains one irrational factor of the form a square minus b square x square, a square plus b square x square, b square x square minus a square, then use suitable trigonometric transformation. So we have already used this one in differentiation, in limit also. So a square minus this, you know, suitable transformation is sin theta, here tan theta, here sec theta. So we have already used this rule. So solve some problem. So write x square by a square minus x square whole to the power 3 by 2 dx. Number 2, dx by 4x minus x square whole to the power 3 by 2. X square dx by 4 minus x square whole to the power 5 by 2, and d, this is dx by x square minus 2x plus 10 whole square. So this is number 4. This is not of the form, but you can use trigonometric transformation. Look, this is not of the above form. This is x minus 1 whole square plus 3 square. So x minus 1 then whole square. X minus 1 equals to 3 tan theta. So we consider 1, 2 and 3. So problem number 3 first. Suppose x square dx by 4 minus x square whole to the power 5 by 2. So obviously trigonometric transformation is in terms of sin theta. So a square is 4, so 2 sin theta dx equals to 2 cos theta d theta. So this is 4 sin square theta into 2 cos theta d theta. So 4 minus 4 sin square theta whole to the power 5 by 2. Now our aim is to remove this fractional part. So 8 sin square theta cos theta and 4 to the power 5. So 2 square to the power 5 by 2. So this is 16 cos square theta to the power 5 by 2. Cos square theta. So cos to the power 5 theta. So after simplifying, we get half outside sin square theta by cos to the power 4. This is 4 minus this. So half into sin square theta by cos to the power 4 theta d theta. So this one is half of tan square theta into sec square theta d theta. Sin by cos, this is tan, 1 cos remaining. So if we put tan theta equals to p, so look, half into p square dp. So finally 1 by 3 p cube plus c. So 1 by 3, what is p? Tan cube theta plus c. Now x equals to 2 sin theta. X equals to 2 sin theta. So we have to write in terms of x. So sin theta equals to x by 2. So if we draw the figure, so this is sin theta. So this is perpendicular. This is hypotenuse. And this is 4 minus x square. So 1 by 3 of 4 minus x square whole to the power 3 by 2 plus c. So using suitable trigonometric transformation, the integrand is transformed to standard form. Then p to theta, theta to x. So look. So in this video, in part 2, we have discussed different methods of solving integrand of function given in the form of irrational function using suitable substitution. So you solve the rest of the problem. Thank you.